All right, Gibson here. So today we're going to take a look at how do we solve rational equations. Okay, we graph them. We've looked at the reciprocal function. We know how to simplify rational expressions, but now how do we solve a rational equation? So that's our objective, simply solve rational equations. Now there's two methods we can use to solve rational equations. The first is we can multiply each side by the least common multiple, or LCM, of the denominators. By doing that, as we'll see in a moment, we can eliminate the denominators and then we have an equation we can solve. The second approach is to set the cross products equal to each other. So depending on the equation we have, one method or the other is going to give us the most effective way to solve the equation. Now, let's do a little review. What do we mean by least common multiple? So if I were to give you two numbers here, 15 and 21, and ask you what is the least common multiple, what we're really after, right, is what's the smallest number that we could multiply 15 and 21 by and get that common multiple. So here's the method we can use to find that LCM. Sometimes it's kind of obvious. We can do the mental math, but when that fails, we can use prime factors to absolutely find the LCM, least common multiple. So let's go ahead and do that. 15 factors into 5 and 3. You guys know how to factor to prime factors. And 21 factors to 3 and 7. The next step is to write each prime factor the maximum number of times it appears in either sets of prime factors. Now this process works whether you have two numbers you're finding the LCM for, or three, or whatever the number. But the second step is critical here. So what will our LCM be? Well, let's start going through our prime factors. We have 1, 5 that appears at least once in the set of factors, so we're going to include a 5. Notice we have a 3 in each factor or set of factors, but the maximum times that it appears in either of them is just 1. So we're only going to put 1, 3 in here. And then the same thing for the 7, it just appears once as a factor of 21, so we include that. So if we multiply those together, we get 105. So that's the smallest number that we can multiply either of the original numbers by and get that 105, right? 15 would be multiplying by 7. 21 we would be multiplying by 5, right? Let's look at a couple more examples here. Find the least common multiple of 6 and 10. Now you could always find a common multiple, right? Just by multiplying these two together, 6 and 10, that would give us 60. But we want to determine, is there a smaller? What is the least common multiple of those two numbers? So same thing, let's factor them into their prime factors. And then we're going to include each prime factor the maximum number of times it appears in either set. So we have 1, 2 in each, so we're just going to include 1, 2. We have a 3 and a 5. So we multiply that together and we get 30, and that makes sense, right? 5 times 6 gives us 30, and 3 times 10 also gives us 30. There's our LCM. Now, does this process work for expressions that have variables in it? Because to apply this technique of multiplying by the LCM to solve a rational equation, we're going to be doing it where we have variables in the denominator. So let's give this a try. What are the factors of 3xy squared? Well, the 3 we can't factor anymore. It already is a prime. We have 1x and we have 2 y's. Let's do the same thing for 6x squared y. This time we can factor the 6 into 2 and 3. We have 2 x's and 1 y. Now we're going to include each factor the most times it appears in one or the other set. Okay, so we have 1, 2. We have 1, 3 in each of them, so we just need 1, 3. We have Now 1x for the first set, but we have 2 x's in the second x. So we're going to include 2. Remember, it's the most times it appears in one set or the other. And then the same thing with y's, right? We have 2 y's in one set and 1 in the other, but we're going to go with the maximum number, the 2 that we see. So we multiply all that together and we get a LCM of 6x squared y squared. All right, so let's jump back into the lesson in terms of how we're going to use the LCM once we find it to solve rational equations. So remember, we have these two methods. We're going to solve the same equation by both methods. So the first one we're going to do is the LCM. Now, let's take a look. It says x over 5 equals x plus 3 divided by 8. So we want to multiply this by the LCM of 5 and 8. So 5 is already a prime factor, right? And 8 we could factor into 2 times 2 times 2, but neither of them are common. So in this case, our LCM is going to be simply the product of the two, 5 times 8 or 40. All right, so let's do that. Notice we're going to multiply both sides of the equation by 40, right? As long as we do it to both sides, we're good. And now we can simplify. And as we simplify, we should get rid of the denominator. That's the whole goal here. So we have a simple equation to solve. So let's do that. The first is 40 over 5, right, which is 8 over 1. We're going to divide both by 5. Now we're going to divide both by 8, so we get 5 over 1. So what do we have? Let's go ahead and simplify. 8x on one side and 5x plus 15, right? I distributed the 5 on the other side. So now we have an equation we can solve, right? Let's gather the x's on the left side by subtracting 5x and then divide by 3, and we get our solution of x equals 5. So there is an example of using least common multiple, multiplying both sides of the equation by that. Let's try the other method where we set the cross products equal to each other, or sometimes you guys say cross multiply. So we get to do that, right? We're going to multiply the denominator of 1 times the numerator of the other side of the equation. So we go ahead and write it out, 8 times x on the left side and 5 times x plus 3 on the right. So if we simplify that, notice we're actually at the same point we were on the other method. And we know that that's going to give us x equals 5 as the solution. Okay, so there's examples of the two different methods. So let's do a few by the LCM method, then we'll do a couple examples by the cross product method. Actually, no, this one we're going to solve both ways. Okay, so let's do the LCM first. So we have 4 and 3 in our denominator. So the LCM is going to be 12. So let's multiply both sides by 12 and begin to simplify. So we're going to get 3 on the left side. Here we're going to divide by 3, so we're going to get 4. So we have 3x equals 4x plus 4. So let's divide or subtract 4x from both sides. We get a negative x equals 4 or x equals negative 4 if we just divide or multiply by negative 1. All right, the other side here, cross products, right? So we're going to say 3 times x and then 4 times x plus 1. So go ahead and distribute, and we can see we're right back to where we were on the other equation, and we get the same result, x equals negative 4. All right, let's try another one where we set the cross products equal to each other. Okay. All right, let's do one that's going to be a little more interesting here. Notice we have an x squared term, and probably the easiest method in this case is going to be by using the cross product, because it's going to be hard to find the LCM of those other expressions. So 5 times x squared minus 1 on one side, 15 times 2x minus 2 on the other. We just cross multiplied. Now let's distribute. And notice, since we have an x squared term, we're going to wind up with a quadratic equation to solve here. So To solve a quadratic equation, we want to get everything on one side equal to 0 on the other. So let's do that, right? We need to subtract the 30x. That gives us a negative 30x. We're going to add 30, so negative 5 plus 30 gives us 25, and now that's equal to 0. Now we want to factor it. Now, I'm not going to show all the steps of factoring, but first we can factor out of 5 here. And then the remaining quadratic, we could factor as x minus 1 and x minus 5. And now, what would the solutions be, right? We have two solutions, x equals 1 and x equals 5. So sometimes we wind up with a quadratic equation we need to solve, but we should be able to handle that. Now, when we get two solutions like this, often one of them may be extraneous. So we've got to confirm, right, are both 1 and 5 valid solutions. So let's put 1 back into the original equation. So, and then we're going to simplify. 2 times 1 minus 2 is going to give us 0. We're going to actually get 0 in both the denominators. So clearly that gives us an undefined condition. Therefore, x equals 1 is not a valid solution. Let's try x equals 5. Same thing, plug it in for x. And this time we get 5 over 8 equals 15 over 24. Is that true? Well, yes. If we divide 15 and 24 by 3, we get 5/8. So we have a good solution there. All right. Let's do another example here. See if you can work through this one yourself. Pause the video and then go ahead and continue. All right, so cross products. So we're going to get 1 times x plus 10 on one side, 3 times 2x on the other side. Let's distribute and then subtract x from both sides to get the x's on the right side, and then divide by 5 when we get x equals 2. Okay, pretty straightforward. All right, let's try another one here. So again, cross products. This generally would be the easiest method to solve equations unless we have two terms or more on one side of the equation or the other. In that case, using the LCM to multiply is going to be your best bet. But here we can still do cross product. So let's distribute. We get some pretty big numbers here. We got x's and constants on both sides. So let's subtract 20 from both sides and subtract 42 from both sides. And now we get x equals 3 as our final answer. All right, let's try another one. So let's do cross products. So if we distribute, you can see we're going to get that x squared term again. So we're going to wind up with a quadratic here to solve. So we want to get everything on one side and 0 on the other side. So let's factor it. First, we can factor out a 2 that's common to each term. And then the remaining quadratic we can factor as x plus 3 and x minus 2. And then our solutions would be negative 3 and 2. And I believe I'm going to leave the work to find any extraneous solutions to you here. But I believe in this case, they both are valid. All right, let's look at another example or two of the LCM method. And here's an equation that I mentioned a minute ago, that we have two terms on one side, right? 1 over 5 minus 1 over 5x. So this is where cross multiplying really doesn't work for us. So first step is, what is the LCM? Let's look at what we have in the denominator. We have an x, a 5, and a 5x. So if we multiply those together, we can simply use 5x as our LCM and multiply both sides of the equation by that. Now, we've got to be a little careful here, especially on the right-hand side. We have to distribute that 5x to both terms here. And as we do this, we should be eliminating the denominator other than just winding up with 1 there. So let's go ahead and multiply everything, distributing. And we can see, all right, I can divide out the x, I can divide out a 5, and this whole thing just becomes 1. So let's rewrite what we have left. 5 equals x minus 1. And now we have a very simple solution, x equals 6. All right, let's try another one, LCM. Right, notice we have two terms on the left side, so LCM is a great method to solve this. So what is our LCM going to be? It's 2x, right? We have x and 2x as our factors in the denominator, so 2x will work. So let's distribute the 2x to all the terms on both sides. And if you see an obvious way to simplify, you can go ahead and do this as you distribute. So that's what I've done here, right? So let's divide out a set of x's. We can divide out a 2. We've already divided out the 2x on the right-hand side. So what's left? We have 2 plus x squared, right? X times x equals x plus 4. Aha, we're going to have a quadratic again. So let's get everything on one side, set equal to 0 on the other. And how can we factor that? We get an x plus 1 and an x minus 2. So our solutions are going to be -1 and 2. And again, I'll leave checking the extraneous solution for you. All right, one last example, I think, here. Let's do the LCM method, right? Because we have two terms on the right-hand side. So let's use 5x as our LCM. So if we go ahead and multiply that and then simplify, right, we can divide out an x in the first or left-hand side, so we're left with 5. And then we can divide out the 5x as we distribute to the first term. That leaves us with 6, but then we still need to distribute the 5x to the 1. So now simple equation, right? We're going to subtract 6 and then divide by 5, and we get -1/5 as our solution. All right, that's it. So we have two methods to solve rational equations, either setting the cross products equal to each other or multiplying by the least common multiple of the denominators. And as we do that, we should eliminate the denominators and have an easy equation to solve. All right, that's it. Thanks.